Use the definition to find the derivative of f of x equals the square root of x squared plus 6x, then evaluate f prime of 2. First thing to do is write down the definition of the derivative. F prime of x equals, the limit as h goes to 0, of f of x plus h minus f of x divided by h. The next thing to do is formulate f of x plus h. That means to take f of x, the square root of x squared plus 6x, and replace each of the x's with an x plus h in parentheses. X plus h squared plus 6 times x plus h. We're going to subtract from that f of x, which is the square root of x squared plus 6x, and then all of that's over h. The definition of the derivative will be 0 over 0, and this is 0 over 0 and will continue to be that indeterminate form until we can factor an h out of the numerator to cancel with that h in the denominator. That's our goal. Right now we're not going to be able to factor an h out of the numerator because our h's are stuck inside of a square root. To be able to get them to come out of a square root, we're going to need to multiply by a root conjugate. We have a root combination in the numerator. It's a root involving h in some way, added or subtracted together with at least one other term. The root conjugate is the same root combination, but opposite sign between the terms, and therefore we'll have a plus between the terms. In order to not change this, we put the root conjugate over itself, a form of 1, so that we're multiplying by a value of 1. So we're not changing the overall value, we're just changing the look. So I will write exactly as we see it in the numerator here in the denominator. And now we're going to multiply these. Now, since the numerators are root conjugates, we're going to FOIL those out. And f prime of x will then equal the limit as h goes to 0 of the first root of x plus h squared plus 6 times x plus h times that same root will give us x plus h squared plus 6 times x plus h. The outside will give us a positive root of x squared plus 6x times x plus h squared plus 6 times x plus h. Since they're both under roots, they can multiply to be under a root. The inside will give us that same expression, but negative, since one of them is negative. And the outside and inside will be the same value except opposite sign, and will therefore be able to cancel. I'm just writing them for the completeness of the FOIL. And then the last is the negative square root of x squared plus 6x times the positive square root of x squared plus 6x, which will give us a negative of x squared plus 6x. But important, put that quantity in parentheses. That negative will distribute on both those terms always. The outside and inside are equal value, opposite sign, and they will cancel. Now in the denominator we do not have root conjugates, so we're not going to FOIL or distribute. I'm going to keep that factored. So it'll be h multiplying that entire root conjugate. Next, we're going to continue to work with the numerator. Our ultimate goal is to factor an h out of the numerator to cancel with that h that's in the denominator. I'm going to FOIL out and distribute in the numerator so that I can combine like terms together. That will give us limit as h goes to 0. We have an x plus h squared. That means an x plus h times an x plus h. We have a positive 6 times x plus h. Let's distribute that, so plus 6x plus 6h. And then we have a negative of x squared plus 6x on the end over here. Let's distribute that minus sign. Be careful with that. So it'll be a negative x squared and a negative 6x. And all of this is over that entire denominator of h times the square root of x plus h squared plus 6 times x plus h plus the square root of x squared plus 6x. Now let's FOIL out the first part of the expression in the numerator, x plus h times x plus h, which will give us an x squared plus an x times an h plus an h times an x, which is 2hx, and then plus an h times an h, which is plus h squared, plus 6x plus 6h minus x squared minus 6x. At this point, we can combine terms together in the numerator. And every time you get to the step where you can do this, the terms that do not have an h in them should all fully cancel. So we're going to see if that's the case. I'm just rewriting the denominator exactly as we see it. We're not going to do any work with the denominator other than once we're able to factor an h out of the numerator, that h in the denominator will cancel with it. And until we can do that, we will continue to have 0 over 0. In the numerator, we have a positive x squared and a negative x squared. We have a positive 6x and a negative 6x, and nicely those all canceled. They did not have an h in them. All of the remaining terms have an h in them, and that h will therefore be able to factor. So we have left a 2hx plus an h squared plus a 6h. All of this is over that entire denominator. So I'll just write again exactly as we see it. And we can now factor an h out of the numerator. And that will leave us with a 2x plus an h plus a 6. And that h that factored can now cancel with the h in the denominator. And that will be our next step. And once we do that, we should no longer have a 0 over 0 indeterminate form. And we should be able to now plug a 0 in to the remaining h's. I will just take one more step to write what we have, which is 2x plus h plus 6 all over the square root of x plus h squared plus 6 times x plus h plus square root of x squared plus 6x. And we can plug a 0 in for all of the h's. Now that will give us in the numerator a 2x plus a 0, which we don't have to write, and then plus 6. And then the denominator, it will be the square root of x plus 0, which is just x squared, plus 6 times x plus 0, which is just going to be 6 times x. And then that will be added to another x squared plus 6 times x. We can now add those roots that are in the denominator. There's 2 of them. So we will get 2 of those roots of x squared plus 6x. And we can actually factor a 2 out of the numerator. We're going to simplify this a little bit further since there is a 2 in the numerator, which can factor. And it will now be able to cancel with that 2 in the denominator. And that should be the most simplified version of our derivative. X plus 3 over the square root of x squared plus 6x. There's our derivative. The other thing we are asked to do here is to evaluate f prime of 2, and that means once we've found the derivative to plug a 2 into it. So let's go ahead and do that. F prime of 2 will then be 2 plus 3 divided by the square root of 2 squared plus 6 times 2. In the numerator, 2 plus 3 is a 5. In the denominator, 2 squared is a 4, plus 6 times 2, which is a 12. We have a 5 divided by the square root of 4 plus 12, which is a 16. The square root of 16 is a 4, and we have 5 over 4.